Now let's look at the example 3 in your textbook. Salifou walks 500 meters due north, then 250 meters due east, and finally 500 meters on a bearing of 0.55 degrees. Sketch a diagram to illustrate his movement. Calculate correct to the nearest whole number how far north Salifou has moved from the starting point. Calculate how far east Salifou is from his starting point. Calculate the bearing of Salifou's final position from his starting point. Take note of this. There's a little mistake with the question in your textbook. The question 4, the sub-question 4 and the sub-question 3 has been repeated, but actually looking at the explanation in the textbook, this is what the question actually meant. So don't get confused. The question 3, the sub-question 3 and sub-question 4 is a repetition of itself. So I've corrected the sub-question 3. This is what actually it means. Now pause the video. Don't look into your textbook. Pause the video. Sketch. Don't look at the sketch in your textbook. Just try it on your own and see whether your sketch will match what is in the textbook or what I have in these tutorials. Pause and try. Now I hope you are done with your sketch. Let's now all do it together. Let's call the starting point P. So I will name a starting point P. This is my starting point. Let me call it point P. Point P. Good. He walked 500 meters due north. I told you about the due north. Due north means an extension of the North Pole. This is my 500 meters. Remember, all other lines will be subjected to this line. 500 meters. So due north. Let me call this place Q. The new position Q. The question did not give us any relative positions, so you can use any letters that you like. And we are using the letters to represent the points. Remember, we use capital letters. We don't use small letters. We use capital letters. Okay. Then he walked due east. That's 250 kilometers. So half of this line. 250 kilometers due east. East. We have to move this direction. Okay, half of this line somewhere here is okay. Due east. This is due east. So let me call this new position R. This new position R. As I said, you have to use capital letters. Then at R, my new position R, Salifou now changed direction. He now decided to walk at a bearing of 55 degrees, and he walked for another 500 meters. So the length of this line should be exactly this one. It's a sketch. You can use scale drawing as I said earlier on. So this is my 55 degrees, and that is his final destination. Final destination. I'll call this final destination S. Now let me indicate the dimensions. This is 500 meters. Sorry, 500 meters. We have, let me use a black color, 500 meters, 500 m. Then we have 250 m, the last dimension, under 500 m. Okay. The question is requiring us to do a sketch of his movement, and that is the sketch of the movement that we have done. That's the first one. So the first sub question has been achieved. We have achieved the objectives for the first sub question, and we are done with that. Let this thing come down small. Let it come down small. Cut it and let it come down small. Or better still, let me see whether we can place it here. Let it just be here. So that is the diagram. That's a diagram for the question, Salifu's journey. Now let's go to the next sub question. It says we should calculate correctly to the nearest whole number how far north Salifu is. When they are asking of how far north, you have to extend the north part of P until become. Let them just illustrate it for you to see how far north will imply. You extend this line up until you become at par. Become at par with the final position. So they are looking for this distance. So you close here. Close here. So how far north? This means how far north. Remember, it's different from how far is it from his final destination. How far is it from his final destination will imply this distance. I hope you get it. How far is he from his final destination will be this. But how far north is the distance? You extend the northern part of the starting point until he comes at par. You come at par. At par with the final destination. Okay, so this is the distance we are going to look for. Okay, this is the distance we are going to look for. So there's something I omitted, the 55 degrees. I just remembered. Don't make that mistake. It's very, very important. When you draw the sketches, you must always put the values of the dimensions given. Angles and everything should be fully represented. Okay, don't make a mistake. Now this distance, we already know one part. We know P up to Q. What is left for us to calculate for is this short distance. So we'll have to do some projections. Now I will draw another line here. I will extend this line, and I will extend this line down. Remember this line is exactly equal to this line. So when I find the value of this line, it's the same thing as this line. Let me call this my new position A. My new position A. And then the new point here A, and probably I can call this one B. So my SB is the same thing as my AQ. So how do I get my my SB? The SBAR is a right angle triangle. SBR is a right angle triangle. So this is 90 degrees. So I can apply either Pythagoras theorem or the basic trig ratio. But remember, before you can apply the Pythagoras theorem, you need to know two sides before you can use the two sides to calculate for the other side. Unfortunately, with this diagram, we know only one side. Okay, so let's now move on to trigonometry. Trigonometry, we must also know one angle and a side, or two angles. One angle and a side. Then we can calculate for another side, or we should know two sides. Then we use the two sides to calculate for an angle. And here we know only one side. We don't know any of the angle here, any of the acute angle. but we know that we can use the projection of 55 degrees to calculate for the value of this angle. We know that the pole place there is 90. So if this bearing is 55 degrees, we'll just subtract 55 degrees from 90. 55 degrees from 90. 55 minus 90 minus 55, and we are going to get 35 degrees. It means the value of this angle here is 35 degrees. 35 degrees. 35 degrees. Good. If that is the case, then we can now apply our trig ratios. Remember the SOHCAHTOA. Now, with this acute angle here, we know this is our opposite, this is our adjacent, and this is our hypotenuse. We are looking for this line, which is our opposite, and we know our hypotenuse. So we are looking for our opposite, and we have our hypotenuse. So which of the SOHCAHTOA, the acronym SOHCAHTOA, which of them have O and H? It is so. So we are going to use sine. We're 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 going to use sine. We know that sine theta is equal to opposite over hypotenuse. So we are going to put our theta in place, which is 35. For opposite, we don't know, BS. Then we put the hypotenuse into its position.